Hello viewers, welcome back to another video. In this video we have a question which has also been adapted from the Japanese physics Olympiad exams, and the question says that how many times larger is the unit size in the SI as compared with the unit size in the CGS system for 2 units of acceleration. Now, this question is also another fantastic question that does not require the use of calculator, and in addition is a question that has been formed from mechanics. Is a question that involves a derived quantity. That does not mean that volume is also not a derived quantity, but in this context I'm talking about a derived quantity that is made up of 2 distinct base quantities, or 2 distinct fundamental quantities. Unlike volume, where you have it as length times length times length, which is just a combination of base units in 3 places, this time around you have acceleration, which is a combination of 2 distinct base units, that is length and time. And so for this question, we would also use our conversion factor. I must point out that this question also does not require the use of calculator. And since we have 2 units of acceleration in the SI unit of acceleration is the meter per square second, which means that 2 units of acceleration in SI would be 2 meters per square second. And so we want to do the comparison just as we did it in the previous video. And so for this one now, all we need to do is just to come up with a conversion factor for length, because in the CGS system, right, time, or should I say units of time, remains invariant. In the CGS system, time is also measured in seconds, same way it is done in the SI or MKS system. So there's no need for us to convert for time or to come up with a conversion factor for time. It is not required. Now, all we need to do in this case is just come up with our conversion factor for length or distance in CGS units. Remember from a previous video, 100 centimeters will give us 1 meter. That is, index 2 centimeters gives us 1 meter. That is what it is saying, which means that our 2 meters per second per square second in CGS units is going to be 2 meters per square second in CGS units would be 2 index 2 centimeters per square second. So if we come up with a conversion ratio as we did in the previous video, that would be CGS per SI. Or let's come up with something different this time around. You can as well say CGS ratio SI. Okay, I think this is better. Okay, this is better. So let's remove this. In this case, it's going to be, for the CGS, it is 2 index 2. That's the magnitude. Now let's ignore the units. Okay, this would be 2 index 2 ratio 2. So that if 2 cancels out, for this one, it's basically going to be index 2 ratio 1. So this is our answer. The answer is index 2, or 100. Now, this question can also be rephrased. Okay, it can also be rephrased as how many times larger is the unit size in the SI as compared with the unit size in the CGS system for 4 units of acceleration, for 9 units of acceleration, for 200 units of acceleration, for 600 units of acceleration, for 9,000 units of acceleration. Regardless of the magnitude of unit of acceleration, our answer would always come out as index 2 ratio 1, that is 100. So that 1 unit in SI is the equivalent of 100 in the CGS units. I hope you've enjoyed this particular video now, and I hope the concept is getting clearer as we proceed with more videos, I will be dropping some trick questions, or should I say play questions, that would further cement your understanding of the basic concepts in physics. One thing that is germane in physics and that most students must master very well is unit conversion. It is one of the, that is why it is usually taught as a first topic in a physics class, unit conversion. Then after unit conversion, we now begin to talk about concepts like dimensional analysis and so on. That is after we've discussed the introductory physics topics vis-a-vis our fundamental or base units and derived quantities now, or derived units as the case may be. So, but for these videos, of course, I want to believe that our viewers are quite familiar with the idea of fundamental quantities or base quantities and their units, and also the idea of derived quantities and derived units. Thank you for watching.